Okay, so this video is going to be a video on how to move from the factored form, or restart. This video is going to show you how to move from factored form of a polynomial to the expanded general form of a polynomial given roots, okay? So let's assume that I am told that a polynomial has roots -4, 5, and -2i. Okay? You should see this. This is normal. -4 is normal. 5 is normal. Whatever. The 2i should stick out to you, and it should stick out to you because of the complex conjugate root theorem. Okay? So you may or may not remember that. So complex conjugate root theorem. If you remember, the complex conjugate root theorem tells me that if an imaginary number is a root to an equation or to a polynomial, then its conjugate, or basically the opposite, is also a root to the polynomial. So when I see this -2i in here, I should know that it has a buddy and that it's also going to be a root. So this -2i being here also implies that there's a 2i also as a root. If you did not pay attention to that, I'm going to catch you on it in the exam, so please remember the complex conjugate root theorem, okay? If an imaginary number or a complex number is a root to a polynomial, then its conjugate will be as well, okay? So now I'm told these things, and I just want to put it into factored form. So if I do that, I'm going to switch to red now. I'm going to start writing these things in factored form. So I know that x, so I'm going to do x, and instead of doing negative 4, I'm going to make it positive 4, so I'm going to do the opposite basically. I have x minus 5, I have an x plus 2i, and x minus 2i. Okay, so I've seen a few different ways of doing this from you guys, and I'm going to show you the way that I think is easiest to keep track of what you're doing. I've seen ways that are mathematically correct, but are a lot more difficult and a lot easier for you to make a dumb mistake going through it, okay? What I normally do when I reach a situation is do 2 at a time, okay? 2 at a time. I'm not going to try and do all 4 because it's a really hard distribution property. In this case, I'm going to start off by doing these 2, and then I'm going to kind of break my own rule for a reason that I will tell you in just a moment, okay? So I'm going to do my distributive property. I'm going to do my first, so I have x times x, I get x squared. Do my outside, minus 5x. My inside, plus 4x. My last, to finish my FOIL, this is -20. I do this, I can simplify it, and I would write x squared minus 5x plus 4x is minus x minus 20, okay? So this is now something that I need to multiply by these 2. In any other case, if this did not have an imaginary number in it, I would tell you to just look at this one and pretend there's not an I there. What I would do, if it was, I would do x plus 2, and I would do the same exact process. I would do this, keep it simple. In this case, I have 2 imaginary numbers here. It's going to be a lot easier for me to do these 2 first before I end up multiplying them both together, okay? So that's what I'm going to do. So I'm going to pull these 2 over here. Okay, so I have x plus 2i. If I do that, I get x squared minus 2ix plus 2ix. So when you multiply these together, the reason that it's easiest is because these 2 will cancel always. And then you have a plus 2i times a negative 2i, which gives me -4i squared. Okay? So we can simplify. We see that these things cancel out. So we're just going to erase them. And remember that I squared really, don't forget this, I squared equals -1. So really I have an I squared, I have -4 times -1, which just gives me a positive 4. So this polynomial ends up being x squared plus 4. Okay? So this is a lot easier than what it would be if you tried to do these one at a time over here. If these weren't imaginary numbers, so listen to me, If these weren't imaginary numbers, I would do them one at a time. So then I would have done I would have done this times x plus 2. And then I would have distributed it, done it with that. Since these are imaginary, I'm doing it this way. Always multiply the imaginary numbers together first. Okay? A little shortcut with imaginary numbers is it's just going to become x squared, and then it's going to be a positive whatever these two numbers multiplied by each other are. Okay? X squared, and then 2 times 2 is 4. Okay? It's a shortcut. We'll see. Once we get to here, this is not completely factored yet, or completely expanded, I should say. So we just need to use the distributive property like we normally would. So I'm going to do x squared times x squared gives me an x to the 4th. I'm going to do an x squared times a negative x gives me a negative x cubed. I'm going to do x squared to the times negative 20, which will give me minus 20x squared. Now I'm going to take care of the 4. I'm going to distribute it to all of them. So I'm going to have a positive 4x squared. I'm going to have a negative x times a 4 is a negative 4x. And a 4 times negative 20 is going to give me negative 80. Okay, now I'm looking at this. I want to simplify it, which means I'm going to combine like terms. It should be fairly easy. X to the 4th, there's no other x to the 4th terms here. X to the 3rd, there's no other x to the 3rd terms. I do have 2x squared terms, so negative 20 plus 4x squared is going to be negative 16x squared. I have a negative 4x and a minus 80. Okay? So in this situation, I have gone from only this information in blue, and really this part. I have noticed that I have an imaginary number as a root, so I use the complex conjugate root theorem, which tells me that its conjugate also is a root. Then I put it into factored form, and then I just use the distributive property over and over again until I finally come down here into the expanded general polynomial form. Really, when you're doing these over here, remember that multiplication you can do in any order. So you could have done this part first, then this. You could do it in any order you want, but just be careful when you're expanding it, just to make sure that you are not minusing a number when you should be adding it or doing something like that. Easy mistakes, which can be avoided if you're paying attention. Okay, so this is how you move from a polynomial, or well, given only roots, how to move down to the expanded polynomial form.